Solve the simultaneous equations 2r minus s equals 10 and rs minus s squared equals 12. Now this first equation here is linear in r and s. So it has terms that have r to the power of 1 and s to the power of 1. It does not have terms like r squared or terms like r times s. We don't see anything like that. So an equation of this form is referred to as linear. In general, a linear equation has the form ax plus by equals c, where a, b, and c are constants, fixed values. X and y are the variables. Of course, the variables don't have to be called x and y. They could be called r and s, as they are here. So the variables here are r and s, or we could use any letters for the variables. Usually letters from the start of the alphabet are used for constants, and letters near the end like x and y or r and s are used for variables. Now, this second equation here is nonlinear because, well, there are two reasons actually. It contains the term r multiplied by s. That makes it nonlinear. And it also has the term s squared. If you see r or s raised to powers that are not 1, then it's nonlinear. If we were to look at these geometrically and graph this, we would get a straight line. If we were to graph this second equation, we would get some curve. Now when I say graph, we're not graphing y against x, but r against s. We could put r on the vertical axis, s on the horizontal axis. For our line, we could just pick 2 points, let r equal 0, then find s. Or let r equal any number and find s. We only need 2 points because this equation is a straight line. Of course, we don't have to have r and s as shown. I could have s here and r here, it doesn't matter. Now for drawing the curve, it's a lot more complicated. 2 points aren't enough for a curve. We would have to work out as many points as we can to get a fairly decent looking curve. So our line might look like this, and our curve might do something, whatever it does. And where the two meet will give us the solutions to these simultaneous equations. Now, I've explained how to solve between a linear and nonlinear equation in other videos. What you do is you take the linear equation and rewrite it so that you make either s or r the subject of the equation. Now, I've decided to make s the subject. That means I've decided to get s on its own. So I've left minus s on the left hand side and brought the 2r over. So if you do that, you get minus s equals 10 minus 2r. Then change all the signs to get minus 10 plus 2r, and I've written it as plus 2r minus 10. It looks better like this. So that's s. What you do then is you plug this into the nonlinear equation. So the nonlinear equation is rs minus s squared equals 12. So we have to replace s with 2r minus 10. So that goes in for s. So we have r times 2r minus 10. You'll have to put 2r minus 10 in brackets because there are two terms in it. Then we have a minus sign. Then we have s squared. We have to square this thing here and set it equal to 12. Okay, if we multiply r into this, we get r times 2r is 2r squared. R times minus 10 is minus 10r. Now we have a minus sign, bracket. We have a binomial here, that is two terms, we're squaring it. We square the first term. 2r times 2r is 4r squared. Multiply the first term by the second term, which is minus 20r. Double it, we get minus 40r. Then we square the second term. Minus 10 times minus 10 is plus 100. Now we have 2r squared minus 4r squared. That's minus 2r squared. We have minus 10r minus minus 40r. Minus 10r plus 40r is plus 30r. Then we have minus 100. And we see that we're going to get a quadratic equation, so I bring the 12 over to get 0 on one side. It's better to change all the signs to make the squared term positive. It's a bit easier to work with. So you can multiply everything by minus 1. So this becomes plus 2r squared. We get minus 30r. When we put these together, we get minus 112. Change the sign to get plus 112. Then we minus the 0. Well, that just stays as 0. So we have our quadratic equation. So we can solve this by using a formula or by factorizing it. I will divide it all down by 2. You don't have to use the formula, but I will do it. I might see if it has factors. 112 divided by 2 is 56. 0 divided by 2 is 0. The factors of r squared are r times r. The factors of plus 56 are minus 7 times minus 8. Minus 7 by minus 8 gives plus 56. But look, you will get minus 15r in the middle. If you multiply like this, you get minus 8r minus 7r. Put them together. Does indeed give minus 15r. So we found the factors of the quadratic equation. And we have 0 on the right hand side. The only way the product of two quantities can be 0 is if either of them is 0. So either r minus 7 is 0, which leads to r equals 7, or r minus 8 equals 0, which leads to r equals 8. So these are the two solutions. So these are the r values of the two pairs of numbers that simultaneously satisfy both equations. So to find the corresponding s values, we take each of these values in turn and plug it into this here. So we have s equals 2r minus 10. We say plug in 7. 2 sevens are 14, minus 10 is 4. So when r is, so for this situation we have r equals 7, we get s equals 4. So that's one pair of numbers. If r equals 8, we get s equals 2 times 8 minus 10. 16 minus 10 is 6. So when r is equal to 8, we see that s is equal to 6. Now you don't have to do this, but I'm just going to show a check of r equals 7 and s equals 4. So if we take our line, which is 2r minus s equals 10, plug in 7 for r, so we have 2 times 7, subtract s, which is 4, and this should work out to 10. 2 sevens are 14, minus 4 equals 10, so that does check out. Now let's try the second equation, which is rs minus s squared. Now this should work out to 12. So if we plug 7 in for r, 4 in for s, subtract s squared, which is 4 squared, we get 7 fours are 28. 28 minus 16 is indeed 12. So it does check out. It should also check out for r equals 8 and s equals 6. Let's just do this mentally. If we put 8 in for r, we get 2 8s are 16, minus 6 is 10. Checks out for that equation. Now let's plug it into the second one. R times s, well that's 8 times 6, that's 48. S squared is 36. 48 minus 36 is indeed 12. So this pair checks out as well. Now we could write our pair of numbers as a point. The first number in the pair is r. Well, it doesn't have to be r, we could make it s, but I've decided to make it r. The second number in the pair I'm calling s. So when r is 7, s is 4. When r is 8, s is 6. We can write as the point 8, 6. You could then draw an s-axis and an r-axis. You could plot the point 7, 4 on it, go 7 units on the r-axis, up 4 units on the x-axis, then plot the point 8, 6, go 8 units on the r-axis, up 6 units on the s-axis. And then we could draw the line 2r minus s equals 10. We know that this is a line, so we only need 2 points to draw it. Now, the other equation is some curve. So it's some curve that actually crosses the line at these 2 points. Now, what exactly it looks like, I don't know. I have no idea really. But that's the geometrical situation. So the curve has the equation rs minus s squared equals 12, and the line has the equation 2r minus s equals 10. And these are where the solutions to the pair of equations are where the line and curve cross. If you want to see the curve, you could go here and type in the two equations, separate them by a comma. Here's the line 2r minus s equals 10, and the blue curve is rs minus s squared equals 12. So you can see it crossing at 2 points. Actually, the curve comes in 2 sections, but only one section crosses the line. This point here actually has coordinates 7, 4, and this point up here has coordinates 8, 6.